Welcome to 8.2 Other Polygons. Okay, so in this section we are going to talk about how to find the area of other polygons. Okay, so far we already know how to find the area of a square, which is s squared or side squared. We also know how to find a rectangle, which is base times height. So now we're going to talk about the area of a right triangle. It's 1/2 the product of the lengths of the legs. The area of a parallelogram is the product of the base times the height, or the altitude. Remember, altitude is the same thing as height, even in a triangle. So let's talk about this for a minute. Before I just whiz right by this, I do want to draw your attention to page 317. There is a proof on how to prove that the area of a right triangle is 1/2 the product of the legs. Remember, a right triangle, the altitude is going to be one of the legs. If you sit up the triangle on one side, that becomes the base. The other leg becomes the height. Okay, so don't be thrown off. It's still 1/2 base times height, but I forgot to mention that on that slide. Also, I won't ask you to make this proof, to prove that it is true, but you should be able to read that proof. It's 14 steps, which seems like a lot, but if you look at it piece at a time, you understand and know the language involved in each and every statement and reason. Okay, so let's go ahead and draw your attention to page 318 while we're at it, because I did just kind of fly by these. There's the exact same thing, a proof that's 14 steps to prove that a parallelogram has the same product as a rectangle. Remember, we said the rectangle area was base times height, so is a parallelogram. Okay, so anyway, we're gonna see the area here. Now the trick though with a rectangle is we can just choose the side, because the side is the height. In a parallelogram, the height is not the side. The side is at an angle. It is not the height of the parallelogram. So in this example, the height is 10. Okay, but the side, like DC, we don't know what the side is. We don't know what the length is. But we do know the base is 25. And we're in inches here. That's what the little quotes mean, inches. And if I just have apostrophe, that means feet. So I'm literally just going to multiply the two together. And remember, my units is square inches. Okay, so now I have the area of a triangle is 1/2 the base times the height. Okay, why do they separate out right triangle from just a regular triangle? Mostly just to show you that the height of a right triangle is the leg. Now here's what happens if I don't have a right triangle. I still need to find the height. So here's example 2. You're very familiar with this. This is actually in feet, but if the height, which is also the altitude, is 9 feet and the base is 12. The thing you have to be careful is 12 is the whole side, the whole base, so that's the length of YZ. Okay, it is not the length of from where the altitude hits to Z. That would be the area of just that right triangle. You wouldn't be finding the whole triangle. So that's the only thing I want to draw your attention to, because that's a common student mistake. So here's my plug and chug, and I've got 54 square feet. Okay, area of a trapezoid. Alright, this one is, I don't know if you've done this one in the past or not. In elementary you may have touched on it, but probably not worked with it a ton. Now remember, a trapezoid has a pair of parallel lines. That pair of lines are different lengths. So we're going to add those two lengths together and call that the base before we multiply it times the height, and then it's 1/2 of that. So 1/2 height times, and then base 1 plus base 2 is in parentheses. Remember, your order of operations is really important on this one. So here's a trapezoid. Now see, I have a base that's 18 millimeters and a base that's 10 millimeters. I need to add those two bases together before I plug it into half base times height. Okay? So here's my official formula. So I'm going to add that 18 and 10 together first before I multiply it times the rest. So it's very similar to the triangle formula. You just have to remember you have two bases to add first. And you get square millimeters. Alright, so let's do another example. Okay, so first, what shape is this? Okay, if you look, they only gave you one side, so we have to kind of assume this is a parallelogram. And if we look at it closely, we're going to be able to see that it is a rhombus. Okay, so rhombus have equal sides, they just don't have equal angles. But it really doesn't matter because the area of a rhombus is the same as the area of a parallelogram. We can still use base times height. And then we are done. But with the area of a rhombus, there's another formula that we can use if we have different information. And that is this formula. So this means half diameter 1 times diameter 2. Now, diameter 1 and diameter 2 are different lengths because, remember, a rhombus is not equal angular. So when I draw those diagonals, they're not the same length, and I'm multiplying diagonals. You're going, if you confuse anything, you're going to confuse the bases, adding together bases for a trapezoid, and multiplying diagonals for a rhombus. That is where a common student error is again. So I'm just heading that off. Remember, rhombus is diagonals, okay, but you can also just use straight up base times height. Just depends on what information you're given in the problem. So here's one where I was not given the base or the height of this rhombus, but I was given two diagonals. Now, the way this is given, it's given you in half diagonals. So I have 6 is just half of that diagonal, 6 is the other side. So one whole diagonal is 12. Okay, so let's go ahead and try to plug and chug in here. So this is where the 12 and the 8 come from because I only am given these, the midpoint, given the bisector measurements instead of the entire thing. So there's one little pre-step you need to do first. And so this area is 48 square units. Okay, so let's talk about a word problem. I have two sides of a tract of land that are parallel and measure 20 kilometers and 30 kilometers. How wide is the property between these parallel sides if the area is 850 kilometers squared? So we need to know what shape I have, which formula I need, and then I'm going to have to solve for a variable because I'm given the area. So let's go ahead and walk through this. It says that two sides are parallel, but they are not the same length, right? So I'm just making up that this is what it looks like. I have no idea if both sides are at an angle or not, but I know that the area is 850. So I'm going to use the trapezoid formula, okay, because the bases are different. That's really all I needed to know, is that the bases are different. And I'm going to plug those in, plugging in all the numbers. I plugged in both bases and the area, so now I need to solve for the height. So when we solve for a variable x, okay, you can, if it's easier for you to put an x in there, that's fine. Okay, I went ahead and simplified that whole side. So if you need to hit pause and work through that and make sure you get the same number, by all means, please do so. And then I got that the height was 34 kilometers. Okay, this particular example is not in your textbook, so hopefully you're following along just as easily as when we were finding area. This one area was given. Okay, so for your whisk summary, I want you to think about some figures here. Consider a unit circle. A unit circle has a radius of 1 unit, okay? And we're going to call that a basic unit of measure for area. So I want you to draw a rectangle that is 4 units by 2 units by sketching unit circles in it. Okay, that's the first step. The second is sketch a circle of a diameter of 4 units and put 3 unit squares in it. Remember, a unit square is just going to have a side of 1, okay? And again, these are rough drawings, but I do want you to use a ruler so that you know if you're doing this right. If you want to use like a centimeter, that would be a good small drawing. You can use an inch if you want to do them larger. And just take a picture and email that to me, and I will